So I guess we're ready to go here. Welcome everybody to the main mid month meeting. And since this is my first meeting of the new year, happy New Year to everybody. Um,
Likewise.
and the disclaimer: please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. And so tonight's agenda um, is Michael. He's going to do a presentation on common mode chokes. So if you're ready to go, Michael.
Yes, I am. I just got to share my screen here, like so. Entire screen, like that. And, okay. So, where's the presentation now? There it is. Can you guys see that?
Yes, sir.
Okay, good.
Got
All
it.
right. So I'm going to go full screen and see if it works. Yes, it works. Okay. So,
Sorry to interrupt, Michael.
yeah.
At the bottom toolbar there says stop recording. Hit the hide button.
What? Oh, wait a minute. I better come back out here. What am I supposed to hit now?
The hide button.
Oh, yes. Okay, got it. Good.
Yeah.
Okay.
Okay. Yeah, because
Right.
sometimes it covers up stuff.
Okay. So let me go back here. Okay. So this is a presentation about common mode chokes. I gave it to our club a while ago. The reason I got interested in this was because I needed to build a common mode choke for my QCX transceiver. I have the 40-watt CW transceiver, and I wanted to take it camping with me. And I wanted to make sure I didn't fry anything. So I got into this common mode choke stuff. So what I'm going to talk a little bit about what a common mode choke is. You guys probably know most of this already. Why do you use it? And I've done a bunch of tests of my choke and in particular, and one of Thomas VA3TMB's choke. He's a member of our club, and he has a choke as well that he's built. So, and I've tested a few others as well. So let's see. These are the chokes here. This one here is the usual sort of coax. You take 4 or 6 inches of diameter coax of RG213, let's say, and you wrap it in a coil 4 to 6 inches in diameter, perhaps, and you use, I don't know, 6 or 8 turns, and that acts as a common mode choke. And it's usually right at the feed point right here. This is another one. It's using RG213 or SL239 connectors, and the choke's inside. This is the one I built based on something that Spingola VA3TMB told me about. It's a bunch of binocular cores like these guys here, and I'm using RG316 because the QCX is only 5 watts at most. So you basically wrap the core the coax through, and there's 4 turns here, and it gets pretty tight because there's not a lot of space in here, but it works, and you just connect it up, and there's two SMA connectors, one on each side. And this is the same. This is Ed's stuff down here. He built a couple. This is a test device he put together to test these things. And the other kind of common mode choke you can use is the coax one, where you put a bunch of ferrite beads on a piece of coax. And there's kits for this, and they have something, I think it's 72 beads or something, and you just wrap them around, put them in, tape them up, and you're done. And here's another choke down here. This is what you get when you do this thing on the left. This is what it looks like when you're done. This is mine. So let's start with this is not a common. This is a choke with 2 separate windings on it, with the ability to connect things together. So a little bit about what these things do. There's a differential mode current, where you put you set yourself up with a choke and you wrap the coax through it. Differential mode means that the current from the source is going down the center conductor, coming back on the shield. If they're both equal magnitudes, there's no current going in the ground. It just connects to the load and nothing happens. The other one on the right, these two currents are both on the shield or someplace, and they add, and you get a ground current. And this is the bad news situation. So let's start with this. This is the differential mode here. We've got a piece of coax, a source, transmitter, whatever, a coax here. On the other end, you've got a coax on the other side, and it goes to the load. So when you wind this thing, what happens is the flux, the current coming in on the top here into the system creates a magnetic field, because you've got these coils wound around the core, creates a magnetic field inside, and you get this flux build up inside the conductor. And it's not opposed, because the current coming back, well, I'll put it this way, the current going through is the red, the current coming back is the blue. This is the shield current, if you like, and the fluxes from the two sources, the current going in and the current going out, are equal and cancel each other. So there's not a lot of flux in here when all is said and done, and that's how that works. On the other hand, if you have a common mode current impressed onto both conductors somehow, the fluxes add as they go through. The directions of the fluxes on each of the two conductors here, the shield and center, let's say, create a large flux inside the core, and the load current basically goes down whatever ground source you've got. When you do that, you get a significant inductance in the coil, in the core. And looked at mathematically, I suppose, if it's a differential mode, which means it's just a normal operation of a coax, the current comes in one side, comes out, back out the other side back to the source on the other side. What happens here is that if you look at the input impedance of this, which is the source divided by the current, source voltage divided by the current, there's two inductances involved. There's the self-inductance of each of the coils, but there's also a mutual inductance between the two halves of the coil. So what you get is a formula that basically takes the inductance, the self-inductance less the mutual inductance, and these are equal because the currents are going equal in opposite directions, same magnitude of inductance. So what you end up with is just the load resistance. So this is really quite small. This is virtually nothing. Virtually no inductance, no very low impedance anyway, just resistive. On the other hand, if it's a common mode situation where both currents are going in the same direction in the core and the shield, then what happens is the inductances add, as you can see in the formula down here. So this is can be a very large inductance. It dwarfs the resistance. So what about antennas? Well, what happens when you have an antenna with coaxial cable feeding it? There's a skin effect happens here. So if you look at a simple ideal dipole antenna, both antenna lengths are sides are the same length, then you'd expect that the current coming out of the into the shield, or out of the shield rather, matches and into the one leg of the antenna matches the current on the other side in the opposite polarity. So you'd think there'd just be the two conductors. and nothing else. But when you look at it, you've got skin effect. Most of the on an AC a conductor carrying AC, most of the current flows not in the center of the conductor, but on the edges, outside surfaces. So there's really three conductors involved at RF. There's the center, the center conductor in the middle has current. You get conductor because the shield, the conductor shield, is not infinitely thin. It has a thickness, so you can have current flowing on the inside surface of the shield, which is what you'd expect to see, because your antenna is connected to both the center conductor and the outside. So you expect to see current flowing that way. But the thing is, it's not always balanced, and you can get current flowing in the outside of the shield as well. And that's the problem, because what that does, if you've got significant unbalance, the outside of the shield acts as an antenna, and it can both radiate energy, because it's a wire with a magnetic field, electric field and whatnot. So it can act as a transmitting antenna, and likewise, it can receive signals, and those signals can get into your radio that way. And you can get RF burns and hot mic situation where you're talking into the mic and you can get a bit of a burn and whatnot, and reflections happen. So it's not a good situation. So this is, by the way, all these, I should say, this is what I understand to be true for all this stuff. And all these slides have come from various different places. This is what one was called the private life of a coaxial cable. And here you've got the red and the green of the legs of the antenna. You've got the current coming in this case, through the center conductor, and coming up from the transmitter on the other side, back from the transmitter on the other side is a current. So these currents are I1 and I2. They're equal. And because there's a very strong coupling between the center conductor and the inside of the shield. But the shield has an outside too as well. And if these two currents, the red and the green current, are not exactly balanced, that means that you get this common mode current, I3, going down the outside. And this is what you got to watch out for. So how do you get rid of it? Well, this is the antenna system here now, with an antenna that's not balanced on the left, the inside, and there's a choke. You put a choke on the antenna side at the antenna feed point. And likewise, you can also put a choke at the input to the transceiver. And these chokes, because they because of the way they're designed, they produce this high inductance, i.e. high reactance, which minimizes the current on the outside of the shield. So that's how you deal with this problem. You put a common mode choke on both sides if you can. And the first one, most important one, has to be at the antenna feed point. And what it does is it induces this large inductance rather, on the outside of the shield, because of the effect of the magnetic core, or the currents flowing through the magnetic core. And that that large inductance created by that large inductance basically blocks the flow. It's a high reactance, and it blocks the flow. And it forces the currents in each leg of the antenna ideally to be equal. And like I said, you can also put one at the transceiver as well. I used to have one on my mini quad. It's got a one-to-one current balun, which is the choke. And I used to have one of the coaxial cable things with the little cores on it. I don't do that anymore because I don't seem to have a problem. But one of these days, I'm thinking what I'm going to do is build myself another core and choke and put it on as well. Anyway, So they're round. The chokes are wound on the particular core. They're ferrite cores, not the other one is called iron powder. I forget. I think it's iron powder. You use the ferrite cores because they're the ones that have the magnetic permeability built in. And depending on which core you choose, the mix it's called, you get different magnetic permeabilities, which creates different levels of internal flux in the core. The one that's recommended for HF is the 31 mix, and that's what all these chokes for HF are using. The HF bands, but if you're looking at VHF and UHF, you want performance, a different type of performance because of the frequencies involved. So typically those use mix 43. And there's all kinds of tables you can find on the web about this. And by the way, there's a document produced by KY9C. It's called an RF cookbook. It's all about chokes and how to use them and whatnot. And the inductance varies with the square of the number of turns. So to an extent, you put more turns rather than less, usually. So there's a couple of ways you can check this out. You can use a spectrum analyzer, or you can use the nano VNA, for example, which allows you to look at filters and whatnot. So what you do is you take the shield of one side of the shield at one end of the core, the choke. You connect that to your tracking generator if you're using a output, if you're using a spectrum analyzer, and the shield at the other end of the core of the coil, choke rather, you connect to the RF input of the spectrum analyzer. And similarly, and you can do the same thing with a nano VNA. You just connect to there's two terminals on the nano VNA. You do the same thing. You connect the shields on both shields to one and the other. And you calibrate it, of course, first to start with. If it's the nano VNA, you use the open, short, and through standards. If it's the spectrum analyzer, you normalize it. Now, I'm mentioning here 6.9 megahertz. That's because for my QCX, it was a 40 meter QCX, so I wanted to look at the 40 meter band. And you set these things up. If it's a nano VNA, you set it up for the S21 mode, which is it measures what's coming out of port 2 as a result of what goes into port 1. And the stuff you see on the web talks about, it basically says that a acceptable attenuation should be anything less than 20, anything more than 25 dB. So better than 25. So this is my, I wonder if I can't do it. This is the my common mode choke. It's a little plastic box. The input, the conductor comes in here, gets twisted. There's 4 turns here altogether on 2 of these cores. You tape them together. In my case, that's what I did. You can epoxy them or whatever. And to stop it rattling around, I put some hot glue. Anyway, so that's all you do. And how I set it up to test, I didn't have the proper connectors really to do this. So what I ended up doing, these are the terminals of the connections to the SA, and basically I used put the power, this would be the tracking generator goes through, and it's connected to the outside by this little panel connector. So you just attach that to you screw it into the SMA connector, and that of course is the shield, like exactly the same on the other side. So now you're connected the signal on the shield side at both ends. And you can also do this, you can look at this if you do the center core as well. As long as it's center core to center core, it works. And this is the differential mode. So you just check, you set up the choke just as you would normally set up a filter, coax in one side, coax out the other. And when you do that, you get very minimal attenuation, like a tenth of a dB, depending, I suppose. And this is my common mode choke, and the range here is this is 7, so this is 6.9 to whatever. Well, 6.9 to 7.3. That's right. Situation is different when you connect it to the shield. You see this significant attenuation, minus 32 dB. And this is well above the 25, with sort of minimally acceptable 25. And like I said, if you do it and look at the center conductors of both at both ends, then it's the same thing. It works the same way. So you get the same kind of attenuation. I tried it. And this is another choke. I have the picture of it. It's a cylindrical choke. It's probably, I don't know, 8 or 10 inches, well, maybe 10 inches long or whatever. Supposedly, this one, the specs on this RF Inquiry 25 CF250 say 50 dB attenuation. I didn't see it. What I saw was around 30 at 7 megahertz again, and it's pretty flat, as you can see. And I guess when you get up to the higher ranges, this one shows it even more attenuation here at the higher end of the HF band. This is the coax bead one, where you take the cores and put them on the coax and tape it all up and whatnot. This is 24 beads. I was wrong about 72. It's 24. And this looks around minus 19 or so. I did actually get a better result with this one, but I don't have it here. Not quite sure why the difference. Could have been a different testing method. I'm not sure. But anyway, this is what you see, and this is the HF band from 3.5 megahertz out to 30 on the other side. 14, sorry, 20 megahertz, 14 megahertz, the 20 meter band. So it's pretty good for what I want it for. And then this is Thomas Bernard's common mode choke. It's a core that's probably, I don't know, maybe 2.5 inches in diameter, possibly. And he's wrapped 6 turns of RG58, I think this was. 6 turns on one side, goes across to the other side, so you get a lot of inductance here, and it works quite well as well. And this is his. So you can see minus 34, well, minus 34, minus 36 at 3 and 7 megahertz, minus 27 on the 20 meter band, not so good on at 10 meters. But what he's using it for is this area in here, so he's pretty pleased. It's better than the 25, significantly better. So to summarize it, you can use common mode chokes to deal with your common mode currents. Acceptable attenuation is minus 25 or better. And this is what I got with these measurements. This one here, the binocular one, is my QCX one. This is the RF9 Inquiry one, not 39, not 50, I noticed. Not sure why that is. And this is the coaxial cable thing, and this is Thomas's core. So that's really all I've got to say. That's really what it's about. Anybody got any questions? I can answer them. I'll leave this connected for a moment. Maybe yeah. Anybody got any questions? Hopefully not.
Or comments?
Or comments.
Yeah.
Nasty comments are welcome too.
Yeah, that the picture you had at the beginning for the different types of balance, the
This one.
The one that uses coax.
This one. Yeah.
No, the one at top left.
Oh yes, up here. Yeah.
Yeah, that's referred to as a dirty bellon.
Oh yeah. Okay. Yeah. Works fine. I
Yeah,
apparently.
yeah, I use one too.
Oh yeah.
Uh,
This is the hour of inquiry one, by the way.
yeah.
Commercial one. Yeah.
Go ahead, Dave. I think it was Dave.
Yep, it's me. I'll need to put my camera on.
Oh hi, Dave.
I just want to show something here.
You're gonna share your screen, obviously.
Nope, just my camera.
Oh, I got to get back to the picture here. Hang on a minute. Yeah. Okay. Yep.
So there, I think my screen just froze. Can you guys hear me?
Yeah, I can see and hear you both.
Okay, because screen, I'm not seeing the screen. What's going on here? Let me see. Okay, there. Okay,
Yep.
so can you see this?
Yeah.
Okay, so I got that. I was walking around with Kevin. Kevin,
Oh yeah.
I built it. I've never used it. It's sitting here. You know, it's too bad I didn't know you were doing this because I would have been happy to loan you this so you could take a look at this and see how this works.
I wouldn't mind looking at it sometime if you're not using it. I'll borrow it and try it out.
Yeah, it says common. I don't know if you could see the writing on there.
Yeah. Yeah, I can see it's on the bottom. I can't read it quite. No, it's still out of focus.
Yeah, it says basically common mode current choke test rig.
Interesting. I didn't know that existed.
You could test it with like if you've got BNC connectors, you've got these are N connectors. So if you've got an N connector or you got a PL 239, so it's got all the connectors. That's got a whole bunch of switches at the back, which allows you to select which connectors and what you want to measure.
Oh yeah. That's
So
pretty good.
yeah, I haven't, as I said, I haven't built this. I built it and I've never used it, so I have no idea whether it works or it doesn't work or what it does.
But you want to, if you're going by sometime, drop it off and I'll check it.
Sure.
I think Drew had his hand up.
I did indeed. That was a great presentation, Michael. Thank you.
Well, thank you. Yeah.
I employed these common mode chokes before I knew anything or I met anybody who knew things and taught me. I bought a couple, and that was to suppress the tremendous 40-meter noise that I have around. And they absolutely had no impact whatsoever. And so they're in a box. And I'm going to go back with the Nano VNA and see whether, in fact, there is anything in the box that I bought. But subsequent to that, I built some. And they are, as you say, they're simple to build. Shouldn't slow anybody down to buy one. I think there's some discussions about the mix you use. I see there's a 61, I think, as well, that I see touted between various wizards on the Facebook page. I could never come to the conclusion as to which is the best mix for this. You're convinced it's 31?
Yeah. Well, I looked at there's a G. I'd have to look. I don't know if it's in my presentation or not. I forget what I put in the references. There's a guy who's now deceased, that British guy, and he has a website G3 something F. I forget.
G3TXQ.
That's who it is. Yes, I guess that's
Golf,
right. And he's
Golf
got
3 Tango X-ray Quebec.
sorry, what?
Golf 3 Tango X-ray Quebec.
Yes, that's remote. That's right. GXQ. That's right. And he's got, if I remember correctly, he's got some tables in his he's got a blog basically
Mhm.
talking about common mode chokes, and he's got some tables in there. Likewise, this KYC.com guy has similar things. He's got a lot of stuff on his website about chokes. But I think it's the British guy that has a lot of information about the different mixes and
Yeah.
the effects and so on. Yeah.
In fact,
I think I bought
Greek guy
43.
has a ton of information on his site. I just posted that link.
Mhm.
Yeah, there's a ton of information there. That's right. Yeah.
I'll go take a look at it. I think I bought 43, and it kind of works, but I don't think it's anywhere near as good as 31.
Yeah,
Yeah, well,
I will try
according
that.
to what I saw, the 31 is good for HF, and the 43 I think is better at VHF and UHF. I think that's what I saw.
Yeah, I was using it for 7 megahertz, and I think the 240-43 was a very common toroid to find.
Yeah.
And so I probably bought a bunch of them, and they kind of work, but I mean, the difference between a choke and a transformer is where I got stuck, and I wasn't quite sure the mix that you should use for each.
Mm-hmm.
I'll take a look at that website and see. Thank you.
You're welcome.
All right, go ahead, Al.
Thanks, Michael. Great presentation. I'm just wondering whether or not you have some insight as to how to size a toroidal core for the appropriate power.
There's stuff on the web. The stuff, I think the Fairlight website has stuff on that. I know the KU9C site has some stuff on that. But basically, you need a larger core for the higher powers, of course. That's what it amounts to. Purportedly, you can use RG316 at 100 watts, but boy, I wouldn't want to do it. I haven't tried it. 5 watts is okay, but you're gonna melt stuff if the power gets too high, I think. So you got to use the larger, and they talk about the sizes of the cores you need. But the higher powers need the larger ones, physically larger.
Yeah, I think I used a T120, something like that.
Could be,
I don't recall.
Yeah.
And it's good for, I think, good for like 150 watts.
Yeah, this I don't know if you can see this. This is that's Thomas's choke. So it's what, 2.5 inches in diameter, something like that. And it's about, I don't know, 3/8, little around half an inch thick. On the cross section, it's about half an inch. And yeah, so, but you have to be careful to make sure you don't put too much power through them. Otherwise, I guess they saturate, and presumably you could damage the cores.
Okay. I can't see.
Drew wants to say something, I think.
Well, just for the power handling, stacking the cores is something I've seen before.
Yeah.
Yes, you can do that as well. That's right.
Yeah, the 240-43, you'll see. I think in the R7, they had a stacked core.
I have an R7. I don't remember what's inside it, but yeah, it could be. Yeah.
Yeah.
If you're lucky, your antenna has a common mode choke internally.
Well, the R7 does.
That's right.
I realize that now, having looked at the box and read about the transformers and the cores, it does have at the just at the coax end before you get to the transformer.
Yeah.
Yeah. Okay. I think Cherry had his hand up.
Yeah, I will make it very short. So great presentation. Thank you, Michael. It's always great to see anything about common mode chokes. In fact, I can look at a picture of a common mode for hours. That's one of my favorite topics. And that G3TXQ, that Ham, who passed away, I think a couple of years back. That person has a great ton of information sitting there in that website. It's good to download that entire website, in fact, because that's a ton of information sitting out there, which is really valuable. And I also note that, like, in that website, there is a 52 series. Out of the 3143, he has also got a 52 being tested, 11 turns on a RG58. And it looks like it has great results on that. I've never been able to test it. Someday I want to do it. But the 52 mix is even better, it seems. Better than 31, better than 43. Some people get better results on 43, but even better results are available on 52, it seems. That's some comment I wanted to pass.
Yeah, if anybody follows the Smoking Ape,
Oh, yes.
he does a lot of work with toroids and chokes and balance and stuff.
Yeah.
And I think he recommends 61 for HF, anyways.
Michael, sorry, are you still intentionally sharing your screen?
No, I'm not.
Because
Oh, am
because
I?
we've been watching your screen. There you go.
Oh, sorry.
Yep, sorry.
Didn't mean to do that.
Yeah, that's because I asked you to close the little window at the bottom.
Okay.
So you didn't see the stop sharing button.
I guess not. Okay. Sorry about that.
Charlie.
Yeah. So my camera's gone for a wander. So sorry, I can't turn my video on right now. I just wanted to mention that the discussion that we've been having around power handling capacity in the toroids, when we're talking about common mode chokes, the actual differential mode signal doesn't create any magnetic fields. So there's no field in the center of the coax. You can have 500 turns or 0 turns, toroid or no toroid. There's no impact on the actual signal. The common mode has an impact on the outside of the coax. And the question then is, how much is the reflected power you're getting back? How terrible is the mismatch? Not to be confused with if you're building something like an end-fed antenna and so on, where you're actually using it as a transformer. Now the size of the toroid is extremely important in terms of power handling capability. Any losses will turn into heat in that toroid. So for a common mode choke, less important if you've got a really good match on your antenna, but then you don't need a choke at all anyway. So if you've got a poor match, you've got a lot of power coming back, and you have to size it for that. But you're sizing for the reflected power, not the forward power. And Michael, great presentation. Just wanted to say, really appreciated it. Great to see.
Yeah.
Right.
It's how you learn doing this stuff, I think.
Oh, absolutely. Eric.
Yeah, sorry, I zoned out. Maybe you mentioned this, or maybe I'm just like super naive, but how does the current coming back manifest itself? Is it noise? Is that simply noise?
You mean the common mode, any common mode stuff you get on the outside of the shield?
Right. Is it noise is the problem? Your signal to noise ratio?
Yeah, noise. It also, I guess, it unbalances the antenna. It just creates basically what it amounts to is if you have any differences, let's say it's a dipole in the length of each leg, you can get this current flowing down the outside of the shield, which you don't want. You want everything on the inside, and that shows up as can be impressed on the antenna as noise or whatever, I guess. Yeah.
Or reduced power going out, or all of the above?
I guess all of the above. Probably it would show up as high SWR, possibly. Haven't really thought about that, but it would show up as it would look like reflected power, perhaps.
It's a great way to get currents in the shack and
Yes.
mess up your computer and all kinds of things.
Turn the signal back on if it's on the same circuit.
It's certainly I wouldn't know from experience what happens, but I've had a
Turns your
computer
house into a bit of a
many times.
poltergeist, maybe.
Yeah, absolutely. Yes.
I've been very lucky. I have never had an RF burn. I've been very lucky for whatever reason. And, I've just been lucky.
So when my hand tingles on my Morse key, that's a problem, right?
Yeah, that's right.
Or you got poor blood flow.
Right. Okay. But yeah, so when you were measuring or just showing the, I guess the scope measurements there with the minus 37 dB, minus 38, minus 39, all that, that was signal that was being measured, right? Signal strength?
Well, it's looking at the attenuation between the tracking generator output and the RF input on the spectrum.
Input, right. Okay.
Yeah. So that's what you're looking at.
Right. Okay. All right. Thank you.
Anybody else? Questions, comments? Okay. Thank you, Michael. That was very good. Very good.
Oh, you're welcome. Glad to do it.
Okay. So anybody want to discuss anything or show and tell anything or anything like that? I do have something, but I would just want to check with everybody else. And
well, if you want to see show and tell, this is my audio amplifier for the backplane and project. It's just breadboarded on a project board. It works. It appears. At least I can look at. It's got two preamps. I can look at them individually and see what the gains are. It's got an LM380. I can see that individually and collectively. They all produce a bit of distortion, which I got to figure out why that is. If the gains are too high. But that's the first step in actually building it on one of the backplane boards. Anyway, that's what I'm up to.
so, how does it perform being built on a breadboard?
It looks fine. I mean, I look at it on the scope, and you can see on the scope. You can measure the gains, and the gains are what they should be based on with an op amp. The ratio of the resistors on the feedback resistor and the one to ground should be the sum. What is it? The ratio +1, and it comes out not too bad. It's pretty close. And the LM380 produces what it's supposed to produce, which I think is 30 dB or something. So you can measure all that, and so far so good. As I said, the only issue I have now is that I'm going to have to do something about the gains of the preamps, I think, because there's too much gain, because you get distortion no matter what the volume on the output is set to on the LM3. There's volume control on the LM380, and it doesn't really matter what that setting is. It's distorted a bit, so I got to figure that out. But it's coming slowly.
Good. Cool. All right. Maybe what I'll do is, okay. So I don't know if you remember. Maybe I think it was last spring. I had purchased one of these little tiny. What do you call them? SI.
Tiny SA.
Yeah. Well, this is tiny. No, one of the little radios. Let me see if I can pull it up here. I don't know if you see. I can't get it to focus.
That's the ATS 21 or ATS 20.
That is the ATS Mini.
Oh, there it is. Yeah.
Okay.
New and improved.
Yeah, this is version 4.
I bought one of those when you first mentioned it, but I didn't upgrade.
Okay. I don't think you really have to. When I showed before, I had the version 3S, and the 3 had some problems. There was an improvement made for the 3S on the front end. With this version 4, The front end is totally redesigned. It's not a plastic case. It's now a metal case. So any outside noise sources are being blocked, but you can still get it as plastic if you want, or ABS. A lot of new features added. Um, I don't know. It's hard to see, but on the uh, well, when I look at the picture, it's on the right side. There's a list. You can now store common frequencies that you want to have. Um, I just got this yesterday, so I'm playing with it now. I've got all the WWV and CHU frequencies on there. I've got some radio stations that I listen to. So it's very easy to set up and save. And anytime I want to use it and I want to use one of those frequencies, I just go to the memory and recall it instead of having to go through and dial it. They've improved the audio out. It's now using a new chip that gives you 1 watt power. There's a bunch of um, additional features they added to it. Um, so far I haven't played much with it, but I'll find out maybe this weekend. Um, Now there's a ham, his call sign OM0ET or something like that. For some reason, they love him to do reviews on products. Uh, there's a version 5 prototype out now for this. And if you actually go to his website, he's got a video. And what they're doing right now is instead of having that little speaker at the back, it's now going to be on the front. The length of the case is going to be an additional inch or inch and a quarter wider, so the speaker can go in there. Um, and they're moving the headphone jack to the top, and the USB charge firmware update on the side. Uh, the actual sorry here, the knob that comes with this one is now going to be on the side, and what they're going to do is use a wheel instead. So now the front profile is going to be flat, and it's going to be a mini encoder. So you still have the capability of changing frequencies, but it also has a button built in so that you can go through the menus. The Now this version 4 has Wi-Fi capability, so you can set up an access point, and you could download radio station schedules and everything into it. But I haven't tried it myself, so maybe in the next couple of weeks I'll be able to play with it. Version 3, I think I paid something like $35 for it. This one's double the price. It's $70. Now, I'm going to play around with this. Now, if anybody is interested to buy one, they get it from AliExpress. There's one particular store I will get it that I order from, and it's an authorized dealer. It's an outside company that's actually designing these little ATS minis, and they're only authorizing 2 stores to AliExpress stores to sell them. So if anybody's interested, let me know. I'll let you know who the seller is, and go to them and get it. And that is it. All right. Anybody else want to bring up any topics or discussion about anything? Go ahead, Drew.
Well, I was just going to mention to our intrepid explorers heading to Montreal, I have a number of elderly computers, of a type that might interest people at such a show. And I was wondering if you'd keep an eye out for information on PDP 1134s, VT100 terminals, and Mac Classics, and just kind of let me know what the interest is down there, what the money might be for it if I was to sell some.
Oh, okay, right. Sorry, I thought you were going down the looking to acquire side of things, but
Oh
no.
God, no! I'm too old to acquire. My wife has told me that my age of acquiring is finished, and my age of divesting has begun. So, yeah.
Hey, Drew, could you post a message of what you've got?
Yeah.
You know, I was going to try to do that on SOAREX, and I'm not sure I have permission to post. I'm going to have to go back and look because I couldn't do it, and I couldn't find out how to do it. So,
What do you mean you don't have permission to
well,
post?
SOAREX is a groups. It's a groups.io, right?
Yep.
Yes.
Yeah, it's
Okay.
just an email. Generate an email and paste everything you've got in the email.
Well, yeah, I'm not. I have 3 or 4. Yeah, I can do that. I'm not so sure. I'm just kind of putting feelers out right now. I'm reluctantly divesting, as we all do at this age. I'm not quite at the panic mode divesting.
Because I might take that VT. Did you say you've got a VT 100?
Yeah, a few.
Like the original deck VT 100s?
Yeah.
Okay, I might be interested in one of those.
You might be interested in Electromedia. I have Electromedia terminal, which is a VT 100 style clone.
No. I was talking about the deck, the original deck VT 100, which was like a big, giant, huge thing, you know?
No, this isn't a giant, huge thing. This has got a monitor, and it's got a slot for the keyboard that slides kind of underneath it, kind of.
Yeah, and it weighs like 100 pounds.
Oh no, I'm sure it's not 100. For shipping purposes, maybe.
I'm exaggerating. It's just heavy.
It's not far off. I mean, I also have an IBM Selectric typewriter that was used as a printer for it, which is really interesting because when you light it up, it, of course, makes the devil's own noise, as Sulu would say, and it's kind of fun.
Or
it takes 8-inch floppies. This 1134.
Even if you take pictures and you put it on your,
I can do that
on your Google Photos, and you just link in the send a post and put the links to the photos.
Yeah. Well, they're not in pristine condition, I can tell you that. But and I have a few Mac Classics with a networking telephone cable between them.
Ooh, nice. I may be interested. You see, I've been hanging around Eric a little too much.
Well, you see, I was kind of expecting Eric to throw his hand up, so I was waiting for that.
Well, see, I'm not quite sure. Just hang on a sec. Sandy, are you still looking for that PDP 1130? You are. Yeah. Oh, she is. Yeah. So,
well, I have one that works. It has RT11 operating system in it.
Does it actually work?
Yeah.
Do you actually? So,
well, I say that I say that hesitatingly. It has been a number of years since I flipped the switch. However, I see no reason why it wouldn't work. I mean, these things are built like the proverbial battleship, and candidly, if it was going to fail, it had ample opportunity. It came from a university divesting of some old computers.
Hey, Eric, you want to make a little detour to Drew?
Dave, we have an extra stop to make in Kingston.
I know, that's what I'm saying.
Well, it's not ready yet. I'm just throwing it out there as
Drew,
you guys are going to the vintage computers.
36 hours, Drew.
See, I understand. So this is. I just thought I'd ask. If you're up there, keep an eye out and see. What if people are interested in these things. They're probably not, because they're not the 1103 or whatever. They're not the big stand-up thing. They're small little desktop. I actually have one that is a desk.
Actually, no, the PDP 11 will be good because I could use it to heat my workshop.
Yes, and it provides interesting noises when it works.
Drew, I will give whatever Dave's giving plus 10%.
I wasn't expecting to start a bidding war, but since it's an open season, yeah. Anyways, just for future, gentlemen, I just thought if you're going down to the vintage computer store, I'd kind of get a sense of what the story is, and if you are involved or interested, then there's always opportunities there. I'm not looking to refinance my child's education.
Well, they do have a they just opened up consignment postings for it. So yeah, there is an active sell buy component to these events. So yeah,
I mean, it's not a market I'm familiar with. I mean, I know what the hams are like, and they're just so incredibly cheap. They they have their own Wikipedia page on cheap. But computer guys might be a little more inclined to part with cash because these are rare and important museum relics.
There we go. I smell the price increasing.
They are artifacts of our history,
Yeah. Well, I mean, if it's taking up space, I mean,
I think that's what my wife was getting at about divesting, is that apparently I take up too much space. Yeah. Anyways, more to follow. I just thought I'd seize the opportunity because I honestly don't know if these things are worth anything to anybody.
Right. Yeah. No. Well, I mean, we're going to the event where that's the lifeblood, right? So.
Well, that's kind of what I was thinking. I'm sorry I can't go. I would be inclined to go, but.
Oh, if you had a TRS-80, I'd be all over it. But.
Well, what about an Apple II Plus clone?
I've got an Apple IIe already, so
an E, that's new.
I know. I mean, it scratches the itch though. So
I have a Toronto clone. I bought it on Queen Street.
Wow, no, that's a little rarer, yeah.
And even better, I have a Diablo SpinWriter printer for it.
My goodness, I thought I had a lot of
and if you want to make a lot of noise and shake a building, this is the one. If you don't have one of those wonderful old teletypes, you could use this and it would really impress people as thinking it is a teletype.
Sounds like you could have your own computer festival, vintage computer festival, Kingston. So
well, my wife suggested something a little more inflammatory, but yes.
Yeah, all right.
I told her most of it wasn't combustible without help, so that saved it for a while.
I kind of know the feeling. When I went down to the VCF East in New Jersey, one of my staff at the pharmacy asked me, "Oh, are you taking the pharmacy computers with you?" Because they were about 10 years old at the time, getting a little slow. So,
well, I prefer to have my computers to have a crank on the side of them. It makes me feel more comfortable.
Right. Okay. Very good. Well, we'll talk.
You bet. I appreciate that. Thanks.
Yeah. All right.
And that's all I have in terms of divesting and pulling people off the core program.
Speaking of divesting, I got my 5-band DXCC recently, and I was contemplating getting the plaque, but it's $70 US plus shipping to Canada and all that stuff. And Marco's comment was, well, if you get that, I'm just going to have to get rid of it later.
That's always comforting, isn't it, Michael?
Begrin?
Isn't it always comforting when they bring that up?
Yeah, we got a basement full of stuff we got to go through and start getting rid of stuff. And I got to get rid of I may have to get rid of my little tin soldier. That when it was wound up tin soldier when in a square on the floor. I have to get rid of that too. Anyway, yeah.
That's worth money.
I don't know. Probably. We went to a store in England once on the outskirts of London that had all kinds of old stuff. Meccano and trains and all that. And I wonder, but I never did anything with it, so it's still here.
Yeah.
Along with my grade one notes and my grade one exam results and stuff, just old stuff.
Maybe Eric.
Yeah, exactly.
Maybe Eric would be interested in your soldier.
That was in the boneyard at Hamvention many years ago.
I'll bet.
I did have something as well, if nobody else is chiming in, but starting to think about FDIM group plans, but FDIM North, as we did last year in May. So FDIM is coming up May 14th to 17th. The actual main event is the 14th, a Thursday. That's the day that all of the talks happen. So anyway, there were 6, 7 of us, I think, something like that, at Smiths Falls last year, and that coincided with the I think Rideau Lakes Amateur Radio Club's Hamfest on the Saturday, so that was a nice conjunction events. Unfortunately, there are no currently listed Hamfests happening on the weekend of FDIM this year.
I think Smith Falls is around that time, though.
Well, they're holding it, I think, on May 2nd this year for whatever reason. It's already been posted.
Okay.
So, yeah, it's unless that changes, but that's what hambone.ca is currently.
Yeah, that would be right. That would be correct. Yeah.
So anyway, we're looking at renting a house again, and having a gathering for a few nights, considering May 13th to 17th. So arriving the day before FDIM, and then spending another couple days after that, the Friday and the Saturday, just working together on group projects and whatever, anything and everything that you want to do. So another excuse for a social event, I guess, in the end. I spent some time looking at a map, trying to figure something equidistant, because we are somewhat far flung now across the province, we'll say. But what seemed to be relatively in the center of things ended up being kind of in the Keswick area. Georgina was a few hours at the most for most people. Maybe 3 to 4 hour drive, something like that, which is not unreasonable, I think, to be as inclusive as possible. So anyway, I have located a few eligible properties, houses that are available during that, I guess, was it 4 nights? 1, 2, 3, 4 nights. Yeah. Ends up costing something like $40 a night per person per night that you spend, depending on how many people come. The more people that come, the less it costs everybody, right? So just divide it up. And anyway, it was a successful event. You can ask any of the people that were there last year and that participated. So always a good time. So anyway, I'll make a post about it and see, get people's interest gauged. But if anyone has any comments, now's the time, I guess, to bring it up.
What are the dates?
May 13th to 17th.
May 13th to 17th. So that's Wednesday through Sunday.
Right.
Okay. All right.
Yep. So that's, like I said, unfortunately, it's too bad there isn't a Hamfest happening or posted yet for the 16th. But man, if something comes up, we may change the location. But anyway, tentatively, that's what we're looking at. So
Okay. I'll have to put out a vacation request. Yeah, it took me 2 years to get to your cottage.
Right. There you go. So anyway, because I don't think too many people are crossing the border. Probably less and less as the weeks and months go by. Less appealing all the time, I think. So anyway, so yeah, that's that. Feel free to message me if you have any comments or anything. But like I said, I'll make a post on SOAREX. I think is probably the best way to do it to gauge interest. So
Okay. Excellent.
Okay.
Sounds like a good time. All right. So, anybody else have anything to discuss or comment or want to add? And shall we close the evening?
I was going to ask, were the gentlemen heading to Montreal going to be here on Saturday morning before they go off?
No, it's Friday that we're passing through, so we'll actually be
Okay.
staying outside of Montreal, Saint Jean sur Richelieu, Friday evening. So
Okay.
it starts early Saturday morning. The event.
I was just going to invite you to the SOAREX breakfast on Saturday morning, but if you're already past us, then so be it. You will miss a wonderful time.
Oh yeah, sorry, that would have been nice. But thank you. Next time, I guess. How often does that happen?
Every Saturday.
Every Saturday, huh? Okay.
Every Saturday, 9 o'clock in the morning.
Right. All right. Well, if I ever find myself in the vicinity on a Saturday in Kingston, so.
And have literally nothing else to do, you can drop by.
As long as I'm not a guest of the federal government or what have you, right? So.
Well, the good news is that we have far less opportunity with that, having closed 2 of our 5 establishments.
Right. Okay. Well, that's still pretty good odds, 60%. Still
Well, it
ready
depends
to accept
entirely on
me.
how you spend your Friday nights. That's how you
Right.
end up there. Or Saturday mornings for that matter. Anyways, I was just suggesting doesn't matter. Enjoy your trip. Do come back with intelligence that I can use to line my pockets, and we'll take it from there.
Right. Okay. Excellent. So I guess the next meeting is the 4th of February.
Yeah, just take a look here. Yeah. Next meeting is 4th of February. Yeah.
Yep.
Well, gentlemen, if there's nothing else to discuss or bring up, let's call it an evening.
Very good.
Night all. See you next time.
Yeah.
Very enjoyable. Thank you.
Have a good evening. Good weekend. We'll
Yeah.
talk to
Night
you
all.
next in a couple of
Good
weeks.
weekend.
Bye-bye.
Yep.